Let's examine how to factor a binomial, that is the difference of two squares. Difference of two squares is abbreviated as the dots pattern. The pattern looks like this. If you're given a binomial that's in the form of a squared minus b squared, so things to note, it has to be a difference, meaning a minus. Your first term has to be a perfect square, and so does your second term. This factors into two more binomials. The pattern is one's a plus, the other's a minus, and you take the square root of a squared, which would be a, and the square root of b squared would be b. In class, we examined why this pattern works, but here's a quick overview of how to do this. X squared minus 16, well, this is a difference, and it's a perfect square minus a perfect square. So this factors into two binomials. The pattern says one's a plus, the other is a minus. The square root of x squared is x, and the square root of 16 is 4. Now, the way to check it would be to distribute or to FOIL, for those of you who use that terminology. To check it, you would do x times x is x squared. The outer product would be x times negative 4 minus 4x. The inner product would be plus 4x, and the product of the last would be minus 16. So we see that these two middle terms drop out, resulting in x squared minus 16. So we did factor correctly. This second one, again, it is a difference, and it's a perfect square minus a second perfect square. So the pattern says one's a plus, the other's a minus. We take the square root of each. The square root of 4x squared would be 2x. The square root of 9y squared would be 3y. So there are my two factors. In the next one, again, I have a difference of two squares. It is the dots pattern. So this factors into a plus and a minus. I take the square root of each. Now, the square root of x to the 6 would be x cubed, because if you think about it, x cubed times x cubed would be x to the 6, because you keep your base and you add your exponents. A lot of times kids think that it's not a perfect square because it's raised to the 6th power, but as long as it's even, it's a perfect square. You just cut your exponent in half. The square root of 25y squared would be 5y. So there it is, it's factored. This final one, x squared plus 121, many kids will make a mistake and try to factor this, but this is not the dots pattern because it's not a difference. Therefore, this binomial is prime. It cannot be factored. Sometimes kids think it can be factored into x plus 11 times x plus 11, but if you distribute, you'll see that this is incorrect. See ya. Now, let's combine GCF and dots together. Your first factoring method is to always factor out the greatest common factor. So when I look at this first one, the GCF would be 3x. So I factor out the 3x, which results in x squared minus 9. Now, I'm not finished, because if you look at the remaining binomial, this is the difference of two squares. So this factors into two more binomials, but what I have to remember to do is do not drop that first factor. So I carry down the 3x, and then this factors into the pattern of dots. So I take the square root of x squared, x and x, and the square root of 9 would be 3. So this has three factors, 3x times the quantity of x plus 3 times the quantity of x minus 3. Again, I need to start by factoring out the GCF. So when I look at this, at least 2 gets pulled out. And when I divide each by 2, that results in 16a squared minus 25b squared. And now it again appears as though I have the dots pattern in the remaining binomial, as long as I put that squared there. I need to bring down the 2, and then this factors into two more binomials. The square root would be 4a. One is a plus, the other is a minus. Square root of 25b squared would be 5b. So there are my three factors. Now, in number 7, this one's a great problem. My GCF is 7x. If I divide each by 7x, I get x to the 4th minus 1. Now, this is the dots pattern. I have a perfect square minus a perfect square. So I bring down the 7x. This factors into two binomials, where one's a plus and the other is a minus. The square root of x to the fourth would be x squared. Square root of 1 is 1. Many kids stop here, but if you notice, right here, again, I have the dots pattern again. So I'm going to bring down my first two factors, but the final binomial there, that's going to split again into two more binomials, where one is a plus and the other is a minus. The square root of x squared is x, and the square root of 1 is 1. So my final factored form, because I have no binomials that will factor further, would be 7x times the quantity of x squared plus 1 times the quantity of x plus 1 times the quantity of x minus 1. Isn't that an awesome problem?